Day 2, we are continuing to review some topics from pre-calculus. The first is polar equations. So we did parametric equations last time. Polar equations today, which is section 10.7 of the pre-calculus book. It's not terribly important. So a polar equation is an equation where the radius is given in terms of its radian measure. So it's going to be written r equals something in terms of theta. These are the graphs that look like all different kinds of crazy graphs. Sometimes you have like the Petal Graph, and they've all got kind of goofy names. You can have circles, you can have ellipses, you can have a circle that starts as a circle, but then it has a little thing cut out. You can have ones where it goes whoop and then continues back around. I don't know what all these are called. They've got official names for them. But anyway, let's try to figure out what this graph's going to look like. You should have received a piece of paper that on the back of it, it's the back of your warm-up problems, has some polar graphs, so you can just put your notes right on there. So we are going to plug in some values for theta, and we want to figure out what radius matches up with that. Some of them are going to be easy to plug in, some are just going to plug into the calculator to get a decimal. We could always get an exact number, but again, finding the exact radius value is going to be tough sometimes. So let's start with a theta value of 0. Sine of 0 is 0. 3 minus 0, pretty sure that's 3. So the way we plot that point is when the angle is 0, so we're looking at this angle here, my radius needs to be 3, so we're going to count 3 units from the origin. At pi over 6, sine of pi over 6 is 1/2, so we have times 3 is 1.5, 3 minus 1.5. So at the angle of pi over 6, my radius is 1.5. And continue on. Pi over 3. Sine of pi over 3 is root 3 over 2. So we get 3 minus 3 root 3 over 2. And then it's calculator time. Type that into your calculator. My batteries are low on my calculator. That's not good. 3 minus 3 root 3 over 2 gives us 0.4. So at the angle of pi over 3, we need to be around 1/2. We're right in here. Plugging in pi over 2, sine of pi over 2 is 1. 3 minus 3, 0. So at pi over 2, I have no radius. And continue on. Uh, 2 pi over 3. 3 minus 3 times sine of 2 pi over 3 gives me that 0.4 value again. 5 pi over 6 gives us 1.5. Plugging in pi, sine of pi is 0. Seven pi over 6. Sine of 7 pi over 6 is negative 1/2. So I've got 3 plus 3 times 1/2. So this one should be 4.5. 2, 3, 4.5. Plug in 4 pi over 3 is 5.6. Plug in 3 pi over 2. Sine of 3 pi over 2 is negative 1. Makes that plus 3, so 6. Plugging in 5 pi over 3 gives me that 5.6 value. And 11 pi over 6 gives you 4.5. 2 pi gets us right back here. So this graph looks like this. That's not great. There we go, not too bad. So it looks kind of like a heart kind of thing. Example 2, r equals -3 cosine theta. -3 cosine theta. Plugging in 0. Cosine of 0 is 1. So we get a radius of -3. So if I have a radius that's negative, so my angle is 0, a radius of 3 would be here. Radius of -3 is going to be over here. My next value is pi over 6. Gives us -2.6. So pi over 6 is -12.6, about here. Pi over 3 should give us -1.5. Pi over 3, this one here, but I'm going the other direction because it's negative, -1.5. Plugging in pi over 2. Cosine of pi over 2 is 0. Pi over 3 gives us positive 1.5. Pi over 6 is positive 2.6. 5 pi over 6. Positive 2.6. Plugging in pi gives us 3, which is a point we already have. And then if we continue on, if we plug in 7 pi over 6, we're going to get this value. This one's going to give us this point again, and so on. If we need a little bit better graph, we could plug in like the pi over 4s. So if I plug in pi over 4, I get -2.1. So on this one, -2.1 would be about right there. We could get another point right up here. And hopefully you're starting to see that we've got a circle. So we're just going to plug some values in. Usually because you're going to get decimals in there, I wouldn't require you to do it without a calculator. We're going to skip this example 3 down here and move on. Example 4. So like parametric equations, sometimes we're going to have to switch back and forth between polar form and rectangular form. So if I've got a point, so here's my graph. If I've got a point and I know the radius, and I know the angle measure here, I could use trig to find the x and the y values. This is my x value, and this is the y value of this point. So we could say cosine theta is x over r, adjacent over hypotenuse. So my x value is equal to r cosine theta. And we could do something similar with the y value. We would get y equals r sine theta. And then another relationship between x, y, and the radius, we could use the Pythagorean theorem here. We know that x squared plus y squared equals r squared. So these are the 3 relationships between x, y, r, and theta that you should know. X is equal to r cosine theta, y equals r sine theta, and x squared plus y squared equals r squared. So in example 4 here, we are given polar coordinates. Polar coordinates usually are written r first and then theta. So this is my radius, this is the angle, even though the angle usually defines the radius. But so we can use x equals r cosine theta and y equals r sine theta. We know r and we know theta, so we should be able to get our x and y, which is what we're looking for, rectangular coordinates. These are usually no calculator, which means you're just going to leave them in exact form. So x equals r times cosine theta. Cosine of 2 pi over 3 is negative 1/2 times 4. And we've got r sine theta. Sine of 2 pi over 3 is root 3 over 2 times 4. So the rectangular coordinates are negative 2, 2 root 3. Oh, there's our equations again. You try part B. Pause the video, see if you can get part B. Once you think you have it, restart the video, and I'll show you the solution. Welcome back. X equals r cosine theta. Y is r sine theta. Cosine of 7 pi over 4. 7 pi over 4 is this one right here. So that cosine, it's over 4, so it's root 2 over 2. Cosine's positive. Sine of pi over 4 is negative root 2 over 2. So my coordinates are negative root 2, positive root 2. So we already went from polar form to rectangular form. We also need to go from rectangular to polar. So this tells us we have the point 3, negative 1. That point's right there. I need the radius, and I need the radiance measure. We can use our x squared plus y squared equals r squared to get the radius. Our radius is root 10. And then we can use trig to get our angle measure. So if I'm looking for this angle right here, I'm going to say tangent theta equals opposite, which is 1 unit, over adjacent, which is 3. Inverse tangent of 1/3. Make sure you're in radians mode when you do it. Is 0.322. This is not our theta that we're going to list as our polar coordinates, because an angle of 0.322, notice, is less than pi over 2 even. That would be like in here somewhere. So remember, your radius that you're listing here starts on this side and goes around this way. I need that angle measure right there. So notice the 0.322 is this much. So if I start with the 2 pi and take that out, that's going to give me the measure I'm looking for. So I want 2 pi minus 0.322. .961. That's the angle we want. And you can list it like that, or you can write it kind of as an ordered pair. Let's do one more of these. Let's do part C, actually. So -7, -2. So -7, -2. Again, Pythagorean theorem should give us the radius x squared plus y squared equals r squared. My radius is root 53. And these problems will be on the calculator part. So I guess you could write it as a decimal if you wanted. I need to get an angle. Doesn't matter if I get this one or this one. I'm going to get this one. We're going to say tangent theta equals opposite over hypotenuse, or opposite over adjacent. So that angle that I found right here is .278. But I need this angle starting here and going all the way around to here. Well, from here to here is pi. Pi plus this amount is what I want. And we get 3.420. Had you found this angle here, so you did 7 over 2 here instead, you would do 3 pi minus that would give us the same value. Last thing we need to do, I think, is to change from rectangular form. So we have equations now. We have an equation in rectangular form and we need to switch to polar form, or we have one in polar form that we need to switch to rectangular form. So on all these, you want to remember the x squared plus y squared equals r squared. X equals r cosine theta, and y equals r sine theta. So here I've got x squared plus y squared. By far the easiest thing to do is just going to be replace that with r squared. And here I've got 2x, so 2 times this. And then we want to solve for r. By far the easiest thing to do, I can divide both sides by r. R equals 2 cosine theta. Part B says x minus 2 squared plus y squared equals 4. You could substitute right away, or like here, I had x squared plus y squared, and if I have that, I can replace it with r squared right away. This one, we do have x squared plus y squared, but we're only going to be able to see it if we expand first. X squared plus y squared. I'm going to replace that with r squared. X, I'm replacing with r cosine theta. I'm going to subtract this 4 over. We can divide both sides by r again. And add 4 cosine theta to both sides. If I'm going too fast, feel free to pause the video, get caught up on the notes. Sorry. Part C, y equals 3x minus 2. Y equals 3x minus 2. Y I can replace with r sine theta. X I can replace with 3 cosine theta. And this time I cannot divide both sides by r. This is divisible by r, this is divisible by r, but this is not, so you're going to get an r in the denominator, which isn't going to help us out at all. If this is the case, put all your r's on one side. Factor out your r. And divide by whatever's left over. And that is the polar form of this line. That's just a line. Doesn't look like much of a line. Straight line, slopes down here, -2, or y-intercepts -2, slopes 3. Yep. Last one, promise. We are given it in polar form, and we need to change to rectangular. R equals 7 cosine theta. Again, we're keeping in mind x is equal to r cosine theta. Y equals r sine theta, and if we happen to have an r squared is equal to x squared plus y squared. First thing I'm going to do is work with this cosine theta. So if I solve this equation, it's going to say x over r equals cosine theta. Multiply both sides by r. And now I've got x squared, so I can replace it with this. It'd be okay to leave it like that. Usually this is a circle. Usually circles, we get them equal to 0. That's it for the notes. We'll be meeting in room 209 here at 10:30 or so. So if you have questions on any of this or the homework as you're going, please bring those questions when we meet.